Alright, in video number 2 for chapter 8, again I have a special guest here. This video 2, is all about following some basic rules, some conditions for being able to do confidence intervals. So I thought, who wouldn't be a better person to bring on about following the rules than Lindsay Lohan? Hi, how you doing, Mr. G? I'm doing pretty good, Lindsay. What's that bottle you've got over there? It's just water. It doesn't smell like water, Lindsay. It's just water, shut up. Okay. Your probation officer gave me a card. Don't you dare call that number. He lies all the time. Alright, well can we talk about some rules for statistics? Yeah, I guess so. I guess that's okay. Yeah, because this fills in like 10 minutes of my community service time. Okay, alright, well that works. So, you're going to recognize a lot of these rules, a lot of these conditions, because they're pretty much all the same from last chapter when we did sampling distributions, but we do have one new rule, and it's a pretty easy one to recognize, and it's this first rule right here. We need to check to make sure that our samples that we are taking are random samples. Either they are simple random samples, preferably, but just to make sure that they say somewhere in the problem that they were a random sample. Okay? Or if we're talking about an experiment, that people were randomly assigned to their treatments in the experiment. And if it doesn't say anywhere in the problem that the sample was not random, then you must write this out, and I have it down there in quotes there, sample not known to be random, proceed with caution. Okay, you can still go ahead and do the problem, but you're just letting, whoever's reading this to know that, our very first condition here, randomness, wasn't met. Okay, but usually it's not a huge issue like assuming some other conditions that we used last chapter aren't true. But we can still do the problem. Just go ahead and say proceed with caution, though. Rule number 2 is for independence. I like independence. Lindsay, you're not going to be getting independence for a long time, sweetie. I'm sorry. Oh, that sucks. Anyway, the second is for independence. And we have done this rule before. We didn't really call it an independence rule, but it says that confidence intervals assume individual outcomes are independent, which means we can use the standard deviation formulas from the last chapter. And remember, for means and proportions, they have their own special formula for standard deviations, and they are in your formula sheets. So you will still need to check the 10% condition, as it was known in the book. That the population, and we didn't talk about this in the last chapter, the population has a specific variable, capital N, and lowercase n is for your sample size. Okay, so sometimes you might see capital N, but not always. Now, we kind of talked about this a little bit last chapter, not too much, but what if the 10% condition isn't met? What if the population isn't larger than 10 times your sample size? Well, technically, there's something called the finite population correction formula. And you can see that I have it kind of arrowed there in both the mean and proportion part. You usually just multiply this after your normal formula, where capital N again is your population size if you know it. That's why we're saying the finite population. It's small enough that we actually know the value of it. And the lowercase n is still your sample size. Now technically this is something we should do, but we really don't have to do this in a beginning level stats course. Okay? So technically you should just say standard deviation cannot be calculated, though technically it could really be calculated. Oh, too far. Alright, and the third rule here, and again this is nothing new, the normal distribution. We must have an approximately normal distribution so that we can still use normal CDF in our calculators. For sampling distributions of sample proportions, we did have that specific rule. The n times p and n times 1 minus p both had to be greater than or equal to 10. I really have to go pee. Lindsay, not right now, sweetie. You can go use my bathroom if you want. Go ahead. Okay, thanks. I'll be back sometime soon. Well, leave your bottle here because you don't need to take it with you. But I'm get really thirsty going to the bathroom. Alright, that's fine. Whatever. Well, anyway, uh, one thing that some people kind of forgot about in the last chapter test was the central limit theorem does not apply to proportion problems. That's why we have this set in stone rule right here. You have to make sure this works. If this does not work, then you say the distribution is not approximately normal. You cannot use normal CDO. Now, for sample means, we didn't have a rule like with proportions. There was no rule to plug numbers in and check. Okay, so this is where, again, we were still at the last chapter, and there are two things you could check. Number one, if they told you that the population was normal or approximately normal, then you could assume that any sample size, for any sampling distribution, will also be approximately normal. Even if that sample size was very small, even if it was only 2 or 5. If the population's normal, your sampling distribution is normal. Now, if they don't say anything about the population being approximately normal, then you got to check number 2. Is your sample size big enough? And big enough, again, was defined as, we might want to stick more with maybe the 30 to be a little bit more on the lesser conservative side here. Then we can use the central limit theorem. The central limit theorem guarantees that if we have a big enough sample size, then the sampling distribution will be guaranteed approximately normal. Okay, so either one of these two things have to be met here. And if both of them are met, hey, great. You just have double the reasons why it's an approximately normal distribution. Really, you just need to have one of those things. So last but not least here, if the n times p condition doesn't check, or again, if neither one of those two things about the population not known to be normal and the sample size isn't big enough, then you just write this, that the sampling distribution cannot be shown to be approximately normal. So no calculations can be performed. You cannot do the problem. You can't use normal CDO because you're not allowed to use it. Okay? So those are 3 conditions for calculating a confidence interval. And you have to check that all 3 of those conditions are met for every problem. And if you don't check them, that's going to be easy points that's going to be taken off on your, on your frappies or on your test or even on the AP exam if you decide to take it. Well, that's all for me. Lindsay says goodbye from the bathroom. I hear her yelling, "Goodbye, everybody." Well, it sounds like she's throwing up or something. Maybe I should go check on her. All right, talk to you guys later.